Okay, so let's have a look at this reaction scheme one here. So let's start with problem one. So when we're trying to fill out reaction schemes, we look at what information we've been given and we fill out the information that's missing. Now in problem one, we're given the reactant, but we don't know what the product are. However, they've told us the reagent, and if we remember from our previous learning about oxidation and reduction, the acidified permanganate is an oxidizing reagent. So actually we can fill in the reaction type this will be an oxidation reaction. And now let's fill in what the product of this will be. Now we can see here that this is actually an aldehyde, and if we remember, an aldehyde can be oxidized to a carboxylic acid, and this is our product. This is reaction scheme 1 completed. Let's look at reaction scheme 2. So here we have a carbon double bond oxygen in the middle of a chain. So this is a ketone. This can't be oxidized, but this is the reactant here. But if we look at the reagent, it's not wanting us to oxidize it. It's sodium borohydride, which is a reducing agent. So what we're going to do here is reduce the amount of carbon-oxygen bonds and turn it back into a secondary alcohol. Now remember, the rest of the molecule is going to look identical. The only difference is the functional group will change from a double bond oxygen to a single bond connection to an OH group. This is reduction, and this is the answer, the molecule that it will look like. Okay, let's go down to problem 3. Problem 3, in this one here, we're given the answer, we're given the product, and we have the reagent as sodium borohydride again. So we know that this is going to be reduction, but what was it reduced from? Well, it must have started with more oxygen carbon bonds, so it must have a carbon double bond oxygen in the middle, and this is a reduction reaction. Problem 4 here in our reaction scheme examples actually has given us the reactant and the product. We just have to say what type of reaction it is and what is a reagent we could use. So we can see that the functional group here is an aldehyde, and it is turned into a carboxylic acid. It's gone from 2 carbon to oxygen bonds to 3 carbon to oxygen bonds. It is increased the amount of carbon to oxygen bonds, so this is oxidation. And there are two things, well, there are actually quite a few, but two ones we could usually use that come to mind: acidified dichromate or acidified permanganate, and I've written that one down here. Let's look at problem 6. So problem 6, we start with this molecule here. This is a primary alcohol because the carbon that the OH is attached to is only bonded to one other carbon. We can see that the reagent here they have is acidified dichromate. So this is going to be an oxidation reaction. And if you notice carefully, there are 2 steps using the same reagent. So I have to be careful not to write the carboxylic acid in here because compound D is going to be the intermediate aldehyde. So let's write that down. So we have the carbon, double bond oxygen, and a hydrogen. This is our aldehyde functional group. And then we do one more oxidation step and we get to a fully oxidized molecule here, and this is a carboxylic acid, and we can't oxidize that anymore. Okay, reaction scheme number 6. We have, this is a secondary alcohol because the oxygen is bonded to a carbon that is bonded to 2 other carbons. They've got the reagent here is acidified permanganate. So this is going to be an oxidation reaction, and of course we are going to add another carbon to oxygen bond, and in this case, because it's secondary, we will produce a ketone. And these are our completed reaction schemes.
Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.